Hello everyone, I am Sarah and today we're going to be acquainted with reconstructing trees, both the step-by-step method and its simple example. So without further much ado, let's get started. Reconstructing trees, the step-by-step method. A cladistic analysis usually necessitates a step-by-step method. Though they appear to be basic, each step takes a significant bit of prior knowledge. Step 1. Choose the taxa. Choose a group whose evolutionary relationships interest you. These taxa will be the tips of your tree and must be themselves clades. For example, you might choose 20 species of beetle that all fall within the same genus. Alternatively, you might choose to reconstruct the relationships among the major clades of insects, such as beetles, flies, moth, butterflies, bugs, dragonflies, and etc., where each taxon includes many species. You will also need to choose an outgroup. The outgroup is a taxon from an evolutionary lineage that is known to have diverged from the group that you choose to study, a taxon outside the clade of the other organisms. If you were studying insects, you might choose crustacean like lobster or arachnid like the common garden spider, since, as we all know, they all belong to phylum Arthropoda. Step 2. Determine the characters and characteristics. At this step, you would be describing a set of characteristics for the group of organisms you have chosen. For example, you might select a suite of anatomical traits as your characters. If we were examining insects, these characteristics might be the number of segments in antennae or the presence of an upper vein on wing. You would next examine your organisms and describe each of the characteristics or character states in a suite of anatomical traits for each taxon. Again, for the insects, you would describe the character states such as whether the insect has 6 antennal segments or has 5 antennal segments, has an upper wing or does not have an upper wing. If instead of anatomical traits, you were examining gene sequences, you might select the 362 bases in particular gene as your character, and your character states would be adenine, thymine, guanine, or cytosine for each of the 362 characters. Note that it is important to select characters that seem to be homologous, that is, characters that are similar because they were inherited from a common ancestor. Step 3. Determine the polarity of characters. Figure out the order of evolution for each character. For example, did the beetle species under consideration all evolve from an ancestor with 5 antennal segments, and only later did 6 evolve, or was it the other way around? Did the lineage with 6 antennal segments evolve into lineage with 5? Figuring out the polarity of character can take some work. In some situations, it is reasonable to assume that the character states in the outgroup are the ancestral states for the taxa of interest. In other situations, paleontologists may have fossil evidence that indicates the probable ancestral state of the character. Many different methods may be used to reason about character polarity. Note that for some types of cladistic analysis, determination of character polarity is not absolutely necessary. Step 4. Group taxa by synapomorphism. Group taxa by derived or changed character states shared by two taxa not by the original character states shared by two taxa. So for example, imagine that we have determined the common ancestor of our beetle clade had 5 antennal segments and passed that character state onto its immediate descendants. 7 of the modern beetle species still have that character. However, one lineage within the clade evolved 6 antennal segments and passed that character state onto its descendants, 14 of our beetle species. According to this rule, we would group the 14 beetle species with 6 segments together, but would not group the 7 species with 5 segments together, because this is the original character state.
Step 5. Work out conflicts.
Work out conflicts that arise by some clearly stated method, usually parsimony.
Lastly, Step 6. Build your tree.
Follow these rules. First, all taxa go on the end points of the tree, never at nodes. Second, all nodes must have a list of derived characteristics which are common to all taxa above the node, unless the character is later modified. Last, all derived characteristics appear on the tree only once, unless the character state was derived separately by evolutionary parallelism. Remember that this phylogeny is a hypothesis. It is supported by available data. But new data or new interpretation of old data could change it. To be confident about your hypothesis, you must scrutinize your data. Now, we'll go through a simple example based on the steps just described.
Step 1. Choose the taxa.
Again, you decide to study the major clades of vertebrates shown in the leftmost column of this table. We have here sharks and the likes, ray-finned fishes, amphibians and primates, rodents and rabbits, crocodiles and relatives, dinosaurs and birds. Many of the vertebrate lineages are excluded from this example for the sake of simplicity.
Step 2. Determine the characters and characteristics.
After studying the vertebrates, you select a set of traits, which seem to be homologous, and build the following data table to record your observation. Note that many relevant vertebrate characters are excluded from this example for the sake of simplicity.
Step 3. Determine the polarity of characters.
From studying fossils and outgrowths closely related to the vertebrate clade, you hypothesize that the ancestor of vertebrates had none of these features.
Step 4. Group taxa by synapomorphism.
Since we have a good idea of what the ancestral characters are, this is not so hard. We might start out by examining the egg character. We focus in one of the group lineages that share the derived form of this character, an amniotic egg, as shown in Table A. We hypothesize that they form a clade, as shown in Figure B. Then we go through the whole table like this, grouping clades according to the derived characteristics as shown in Table C.
Step 5. Work out conflicts.
There are no conflicts here. Every group is a subset of another group.
Lastly, Step 6. Build your tree.
Based on the groupings above, you produce this tree. Voila! You have made a phylogeny. Of course, this was just an example of the tree building process. Phylogenetic trees are generally based on many more characters and often involve more lineages. For example, biologists reconstructing relationships between 499 lineages of seed plants began with more than 1,400 molecular characters. And that's for my topic, Reconstructing trees. To learn more about cladistics, let's listen to the next discussion.